Greeting of the day and welcome to the lecture. Second, introduction to sensors and transducers. So we will just take a brief overview of the last lecture, that what are the course objectives and what are the learning outcomes of this particular subject. I have specified the 5 learning outcomes of the subjects based on which we people are supposed to study the following contents. Introduction to sensors and transducer. This is the basic lecture which focused on the introduction of sensors and transducers. So whatever the points that we people are going to discuss, that has been highlighted in this particular slide, that consists of what is sensors, commonly detectable phenomena, physical principle, that is how sensor works, need for the sensors or need of the sensors, how to choose a sensor, its example and references. This is the brief overview which we people are going to see in this particular lecture. Now, what is sensor? In the first lecture also, we have discussed that human body is one of the best example of the sensor. Suppose as an example, if we have placed a heated candle below the hand, at that time we people try to move that particular hand away from the heated candle or the flame across the candle. So it seems that your hand is having a sensation and you are trying to move away that particular hand from the flame or above the flame. But as per the standard of American National Standard, it has been defined that it is the device that provides a enable output in response to a specified measure. It means that some input has been given to the sensor and you people are getting the output. We will consider the previous example that we have placed one hand on the flame and we are trying to move that hand away from the flame. Reason is that your hand is unsustainable to that particular heat. It means what is the input is nothing but that heat, and output is moving motion of the hand away from the flame. Now sensor acquires a physical quantity and converts it into a signal suitable for signal processing. For example, it may be in terms of optical, it may be in terms of electrical, it may be in terms of mechanical. That may be any physical quantity, but it will be in this particular 3 form. That may be pressure, it may be temperature, it may be vibrations, anything, etc., etc., etc. That we will see in the day. Nowadays, common sensor converts measurement of a physical phenomena into an electrical signal, or active element of a sensor is called as a transducer. Now, what is active, what is passive, that we people will see in detail in transducer. So, transducer, a device that converts one form of energy into another form of energy. Now, when a input is a physical quantity and output is a electrical one, that is the sensor. And when input is electrical and output is physical quantity, that is actuator. Now, these two terminologies are vice versa to each other, and the below diagram shows the example that is representing some physical parameter. Suppose we have given a pressure to a particular sensor or a transducer. At that time, with reference to that of input, your pressure, it will try to generate a electrical signal. For example, thermocouple we have considered, that is a temperature sensing device. Now, when your temperature start rising or increasing, at that time the output voltage generated is in terms of millivolt, and that will vary based upon the variation in the rise in temperature. The another example for this particular one is piezoelectric, that is force is converted into voltage. If you apply force on piezoelectric crystal, at that time proportion of the force which has been applied on the piezoelectric crystal, it will try to convert that force into a electrical voltage. It means voltage force ultrasonic. Now, for your second point, that is when input is electrical one and output is physical, that is nothing but actuator, your microphone, your loudspeaker, in that one, your electrical parameter is converted into physical parameter. So microphone, when I am speaking, this is the best example while recording a video lecture. There is a microphone situated in the laptop, and that laptop captures my sound and it converts into the sound. Similar to the speaker where we people are visiting at that time during announcement, that sound is converted into the electrical signal is converted into a sound. So these are the two different points. That is, one is sensor, which converts your physical parameter into electrical one, and the another one converts your physical electrical output into a physical quantity. Now, commonly detectable phenomena. So there are many more parameters. Some of the parameters that we have considered, maximum parameters that has been considered over here. First one is biological, then chemical, electrical, electromagnetic, heat, temperature, magnetic, mechanical motion, that is nothing but displacement, velocity, acceleration, etc., optical, and radioactive. So these are nothing but these are commonly detectable phenomena. So common conversion methods that are used to convert that particular parameter. First one is your physical, thermoelectric, thermoelastic, thermomagnetic, thermooptic, or photoelectric, photoelastic, photomagnetic, electroelastic, electromagnetic, or magnetoelectric. So these are nothing but these are the physical points or physical parameters that we people are thermal quantities converted into electrical. Now temperature is converted into volt. That is the best example. Or temperature radiation in terms of non-contact type of sensor, temperature is converted either in form of light or in form of electrical voltage or motion. It can be converted into voltage, current. Likewise, these physical parameters are converted. In chemical transport, physical transformation or electrochemical signal. In biological transformation, physical transform takes place. Now, commonly measured quantity, stimulus. What is the input that has been given and what output you people are getting? That is the quantity. Acoustic. Acoustic is nothing but it is the signal and it is represented in form of wave or amplitude, phase, polarization, spectrum, wave, velocity. Biological, in case of biological and chemical stimulus, fluid concentration, for example, gas or liquid. Electric charge, voltage, current, electric field. In that one, electric field, your amplitude is there, phase is there, polarization is there, conductivity is there, permittivity is there. So these are nothing but these are the quantities which is correlated with the electric one. Then magnetic field. In magnetic field also you people are having amplitude, phase, polarization, flux, permeability is also there. Depending upon the flux linkage and your permeability, you can define or you can correlate the strength of magnetism. Then optical, your refractive index, reflectivity, absorption. In thermal case, your temperature, flux, specific heat, temperature, conductivity. In mechanical, you people are having position, velocity, acceleration, force, strain, trace, pressure, torque. Likewise, all the above mentioned stimulus are correlated with its quantity. to generate the output. Now, physical principle, for example, Ampere's law. A current carrying conductor in a magnetic field experience a force. And for this one, the best example is galvanometer. So when a current carrying conductor in a magnetic field experience a force, at that time that particular needle that will try to deflect depending upon the magnetic field that has been generated. Curie-Weiss law. There is a transition temperature at which ferromagnetic material exhibits paramagnetic. And Faraday's law of electromagnetic induction, a coil resists a change in magnetic field by generating an opposing voltage current. For example, your transformer. It may be step up transformer, it may be step down. Then photoconductive effect. When light strikes on certain semiconductor material, the resistance of material either it will decrease or either it will increase. So here your photoresistor is the best example, in which what happens when light rays incident depending upon NTC or PTC, that is nothing but positive temperature coefficient or negative temperature coefficient, your light radiation which are falling on the semiconductor material, its resistance will vary, and in proportion to change in resistance, the resultant output generated across the output, it will change. Means Ohm's law, if we try to apply, V is equal to IR. So when your voltage is directly proportional to the resistance, at that time, what is going to happen? Your resistance increases, it will try to decrease the voltage. And when your resistance decreases, at that time voltage will increase. Now, how to select sensor or how to choose any sensor or transducer? First parameter that you have to consider is environmental condition. Second one is economic factor. And third one, what is the sensor characteristics? Now, while designing a particular instrument, it requires some sensors, but it should not happen that the cost of that particular device or the instrument which we people are designing is more than that of its selling cost. It should be affordable to the common people while designing that. Now, what application we people are considering depending on that particular application? Actually, suppose we are interested to measure the temperature of a certain range. There are large number of temperature sensors. For example, there is a thermistor, there is a thermocouple, there is a RTD, there is optical pyrometer, and many more. Thermopiles are also there. So these are nothing but these are some of the temperature sensors, some of the temperature transducer, based upon which we people are trying to select a temperature sensor. Now, here while selecting that temperature sensor, or we have to consider up to what extent we people are interested to measure the temperature. And depending on that, we are supposed to select the temperature. Second means that if suppose your temperature range is high and you have used the material to design that particular temperature one is having the low coefficient, at that time that material will melt. So you have to take that particular condition. You have to consider that condition, and based upon that you have to design. It means the another thing that you have to consider, the environmental change in temperature should not affect the response or the output of the instrument that has been designed. So environmental factors to be considered while selection that will not affect that particular sensor or transducer or instrument. So first parameter is temperature range. In the room condition or room temperature, it should